Okay, so I set myself a target and I usually do the first presentation on most of these summits, and I look at what I did in the previous summits and see whether I can add something extra and new. And luckily the Wi-Fi industry also keeps moving quite fast every year, so it's easy to kind of update the presentation with new things which have happened. So I'm focusing on some of the new things relative to last year. A few things of course stay similar in the sense that we've been talking about 11AX for the past couple of years. So I think that still remains probably the hottest item from a overall Wi-Fi perspective, but we are at a different stage of 11AX probably compared to last year. So let me also outline where we are talking to various people and giving you a flavor of that. Okay. So I'll start with 11AX, or of course definitely new compared to last year is this branding called Wi-Fi 6. Then another hot news, though maybe in India it might not be still relevant, is new spectrum coming to Wi-Fi. Security related things are the ones which made a lot of news as well with WPA3. On the product side, retail product side, there are mesh sort of enhancements. And then if you are wondering what happens after 11AX, I mean, is there anything coming up, then quick answer is yes. So we'll also end with looking at what is coming beyond 11AX, and then give you a big picture view of Wi-Fi in terms of where all we see Wi-Fi, what are the various tech, what are the relevant things, etc. Okay, so that's my summary of talk. So let me start with what I usually flash, but this time with a small addition that now we have this branding of Wi-Fi 6 for 11AX, and this was a you can say orchestrated move by the Wi-Fi community, primarily to position themselves as something which is worthy of being better than 5G, or at least something where they are not lost out in that 5G noise. Okay, because we of course are bombarded with a lot of news about 5G, and so people keep wondering what's happening on the Wi-Fi front. And so I think the Wi-Fi Alliance along with its members decided that we needed a branding which probably says that we are ahead of the game, right? So Wi-Fi counted down the sort of evolution through which it has gone through. So your 11AC will now be branded as Wi-Fi 5, and of course the 11AX comes as 6, and your Wi-Fi will show up primarily with an icon which says something like a number relative, meaning let's say if you're connected to 11AX network, it will show up with a number 6. In fact, we had the first client devices coming to the market just recently, Samsung Galaxy 10. So if you see some of the videos out there or images out there, you will see the picture of that icon Wi-Fi 6. Okay. So of course, although in fact long back when 11AC was announced, there was an attempt by some people to call it 5G Wi-Fi, but it didn't take off as a branding. But now Wi-Fi Alliance has formally agreed to that. So just to recap, bandwidths of course are increasing. This one stands out. So it looks odd, but 11AD was an attempt at 60 gigahertz. It has really not gotten on to the mainstream Wi-Fi product market. That doesn't mean there is no life, and I'll talk more about it towards the end. But definitely it doesn't have the number, this could have been 6 and that could have been 7, but they have not given that number to 11AD right now. So it is usually known as Y-gig informally, but we will see when it kind of attracts as much attention as say 11AX or 11AC. Okay. So bandwidths are increasing, the channel bandwidths are increasing. Just let's skip this and go here, but no difference from 11AC to 11AX in terms of max bandwidth capability. And even even when I talk about the spectrum matter, I'll raise the question that even this is a somewhat debatable bandwidth, in the sense it hardly gets used in practice because of the constraints of the channels that we have. Okay. And technology wise, we have moved from spread spectrum based systems early on to OFDM included MIMO. Then we have now OFDMA as the access technology. Thank you. Right. So that's now almost in line with what cellular is doing. Okay. And peak data rates, which have been always the key thing in Wi-Fi, And if you look at it, 54 to 600, 600 to close to 7 gigabit per second, but this jump is not that significant. So you must understand that 11AX was not looking at peak data rate as that important a metric. More importantly, it was looking at what we call as high efficiency. So sometimes you will hear 11AX referred to as high efficiency wireless LAN. Okay, but that then puts the spotlight on 11AX primarily because now 5G has upped the ante and said, hey, we have very large numbers. So what are we going to do? And so that's why EHT after 11AX is kind of started before we have 11AX products, so that we can kind of get back on the speed race, so to speak. Okay. Bands wise, of course, 5 gigahertz is now quite heavily used, and so that's the reason for the drive towards 6 gigahertz. 11AX will play in both 2.4 and 5, okay, unlike 11AC products. So in that way, we are kind of keeping all bands open, and we'll see some interesting stuff happening closer to the end of the presentation. So just to remind that 11AX always can do the old style transmission, which is what we call loosely as a single user transmission, AP to one user at a time or one user to an AP at a time, ideally speaking. And now we are moving to this paradigm of multi-user transmissions, where AP to multiple users or AP scheduling multiple users to transmit to the AP. And this can happen in a variety of ways. OFDMA is currently the most popular mechanism, and I'll list out why that's so. MU-MIMO has been around on the downlink for 11AC, very debatable as to what benefits it is actually given, but still it has some life. And uplink MU-MIMO probably will come to the market sometime when things are stabilized a little bit. Okay, but I think the first wave of products which we are likely to see are predominantly going to definitely support OFDMA on downlink and uplink, and some might support the downlink MU-MIMO as well. Okay, and of course you can always have the mode where you can combine OFDMA and multi-user MIMO, and that's the most you can say advanced mode of transmission, and that's likely to be happening sometime later. And this is the sort of dream of the high efficiency group, is how do we get the air to be utilized efficiently as compared to the previous ways. Can we pack transmissions going to multiple users, because the overhead for waiting and back off, all those things are amortized over transmissions to multiple users. Can we pack not just the data for multiple users, but along with that schedule for the uplink with the data, and not just for the users who are having data, but even for users who don't have data on the downlink, and then get all of them to transmit simultaneously on the uplink and send an ACK in parallel to everybody on the downlink. So that's the sort of the dream of an high efficiency system, where you want to get things without too much wastage of the air. You want to get things happening in parallel, and that was the dream of 11AX, right? Are we going to see that in our first round, assuming that we will get OFDMA working? Not quite, as you will see that this will take probably some more time to realize this in the full-blown way that the standard envisaged when they went in for OFDMA. It might take some time for us to get here. So what will happen in the initial few runs, which we will see? And that is really driven to a certain extent by some of the waves of certification that we are looking at. So wave 1 is more likely to ask for a mandatory support of that one, more like an optional support for this, and a few other features which we'll have to wait and see whether these things really become mandatory, optional. I'm sure there will be people who are going to fight on this, but I think what we are likely to see is definitely consensus on everybody agreeing to support. Definitely this can potentially be realized through OFDMA, okay? But are we going to see the full-blown one? And of course some of the other features like uplink multi-user MIMO, the combination of multi-user MIMO, these are probably post 2020. When is the first certification wave likely to come out? Sometime this year. This is expected probably early half, but probably now just after the first half is when we are likely to see the certification likely to happen, okay? Is it because this is probably a big leap for the Wi-Fi community in terms of a technology where we have a scheduled mechanism also brought in, multiple users being asked to transmit at the same time, multiple users getting data at the same time. So these are some things which are somewhat very new to the Wi-Fi world, and I think so it will take some time for them to kind of get it working somewhat at least stable, not maybe optimized way, but at least to make sure that it doesn't crash. You know, people should not have a feeling that 11AX means that I'm not just going to get anything working, right? So in the interest of that, instead of overloading ourselves with all the features, what we are likely to see is something like this. So on the downlink, definitely we can have data going to multiple users, either OFDMA, which might be mandatory, a multi-user MIMO if, for example, you support that feature, okay, downlink MU-MIMO feature, okay. But for getting the acknowledgement from the users, we might not be piggybacking a trigger along with the data. We will send a separate special trigger frame, which is a multi-user block ACK request, which will basically imply that we are not bundling this along with this in the first stage. We are going to put this separately to entice people to send ACK. Okay, so it may not be as efficient as what we envisaged in the first picture here, where we also piggybacked a trigger along with the data, right? Here we are saying that let's keep the data separate, let's keep the trigger separate, but at least we have achieved the efficiency of data going in parallel, ACK going in parallel, and not too much gap between all of these things. So in that sense, I think it's a definite efficiency improvement, probably not, as I said, the best that we thought we could do, but we are getting good kind of improvements over some of the earlier techniques. So that's on the downlink, okay. On the uplink, again, trigger will be what we call as a standalone trigger frame, okay. And the standalone trigger implies, again, I'm not going to combine trigger and data, it's standalone trigger enticing data from multiple users, okay. This is most likely going to be only uplink OFDMA to start with, and then an ACK which goes out in parallel to multiple users, and that can be even slightly more efficient than multiple MAC ACK messages. That can be a multi-station block ACK, which will save some bits in MAC headers which might have to be constructed if you had to send ACK separately for each user, okay. So this is likely to be our first round of products support, where they are not going to attempt everything that we probably envisage, but gets at least some of the things that we had in mind out into the market and see the benefits of that in terms of better utilization of the air, okay. Now one of the things which has not been talked about so much on the OFDMA front especially is the range impacts and this can be useful especially for certain low power devices or IoT class devices, etc., where because we have this what we call a 2 megahertz possibility now, instead of always limiting your transmission to 20 megahertz where you might be below the noise floor, now you have the possibility of a 2 megahertz transmission going above the noise floor, okay. So this can help in certain coverage constraint situations where an IoT device or a device with low battery or low power could just kind of use this feature and get working with the access point. And if you want proof of how that impacts performance, IEEE has some simulation results where for example they've considered only the uplink full buffer. And you will see, for example, many people claiming my access point can support 36 simultaneous users, or somebody with 160 megahertz would say 74 simultaneous users. So here the simulation only captured the 80 megahertz 37. This is the max number of users you can support in one go with 80 megahertz. And so they placed stations at different distances and did a bunch of simulations, you can see, right. And what they did was they said let's put the stations right at the edge, which is 55 meters in this case, and they compared the legacy non-11AX with the 11AX OFDMA and looked at the benefits. And so you can see there's a 15-fold improvement in the gain that they got in this UDP throughputs. Where does this gain come from? Predominantly this comes from two factors. One is the efficiency improvement that was the reason for choosing OFDMA, one, and the add-on effect is the fact that we also get the range benefit which translates here into a higher MCS compared to if you did not use OFDMA. Okay? So these two combination sort of combo benefits is what gets you this place giving you higher compared to, let's say, if you are right at the cell close to the access point, you don't get the advantage of the OFDMA MCS improvement by concentrating your signal on a narrow bandwidth. Okay? So here you get the benefits of what we call efficiency, where you cut down all the waiting times, etc. Here you get the efficiency of the OFDMA protocol plus the gains due to the MCS here. Okay? And that carries over in case you want to distribute the stations across, you will still see some gains. The target for the 11AX committee was that they wanted to see a 4x improvement. Okay? That was their in their project authorization request, they had submitted that they will be 4 times better than the legacy. So clearly on the average they counted down this and they said that it definitely can be justified that it can give you 4x more. And they have results on the TCP side as well, which shows some good improvement. So overall there is data to show that if we get things right, we can get some good numbers out of this OFDMA kind of system. Okay? So now what about MU-MIMO? So MU-MIMO is kind of in the news in 11AC, and it's a very contrasting sort of story, I would say. Nobody knows whether MU-MIMO has really made any big difference or has it hurt them. So I think still people are sitting on the fence as to whether they should turn it on. So there are people who have bought the product and turned it off, right? And there are people who are running with it and then they face some difficulty. So I think it's a challenge to understand. So 11AC downlink MU-MIMO does have some serious challenges. And one of them is that the feedback process has been very inefficient because it's what we call as a poled serial feedback. So you basically waste a lot of time asking everybody for sending their feedback. The feedback itself is a big frame, thousands of bytes typically, and then on top of that you have to poll. Each of the polling ones have a preamble attached to it, so it just becomes a real guzzler of airtime, right? So one of the things that 11AX did was, because we have OFDMA as a mandatory feature, let's use OFDMA for getting the feedback in parallel from multiple users. Okay? So when the AP sends a sounding frame and identifies, let's say, 3 users, these 3 users can now send their feedback in parallel. So they don't have to be polled individually. They can just react to that particular one single poll and send their feedback in parallel. Still, a lot of improvements possible with respect to this whole mechanism, because compared to, let's say, cellular, which found a very nice way of exchanging that feedback related to this you can say MIMO channel conditions, which is just share an index, right? Here we share, you know, literally a whole big matrix which is like thousands of bytes. So that is still a blocker, I would say, for getting the beamforming and MU-MIMO to become really more efficient. And so that's something that we will see happening in the next stage of the standardization. Okay? Now one of the offshoots of the progress towards 11AX is we are seeing 8-stream products coming to the market. Now there are probably very few 4-stream clients. So where do we expect an 8-stream client to suddenly appear in the market? But the nice thing is that one of the advantages of an 8-stream AP is that it's not probably aimed for an 8-stream client, it's aimed for having multiple, you know, 2-stream or combination of a 2-stream and on 1-stream to be addressed using an MU-MIMO transmission scheme. Okay? So in that sense, getting this 8-stream product up in the market makes DL MU-MIMO to be more effective for more than 2 users with multiple streams. So hopefully we will see better MU-MIMO performance as we get this 8-stream product rolling in the market. Okay. Still I would say MU-MIMO has to be used rather cautiously, knowing when it might click and when it might really have an impact. OFDMA probably is a little bit more easier to justify. And that is what I have just documented, that OFDMA has wins out on the complexity aspect. There is no sounding or feedback. It can be used for a variety of SNR conditions, and it also shows up as a big number for people to advertise, saying that hey, my AP can support 74 or 37 or whatever number that you want to advertise as a part of your offering. So that gives them something to shout as compared to the previous generation products to help them get the message across. Downlink MU-MIMO is still bogged by a lot of complexity, sounding, etc. Definitely has constraints on when it can really make an impact, both in terms of SNR conditions as well as sizes of frames, etc. Of course, if it clicks, then it has great spectral efficiency enhancements to bring in. Okay. So in that sense, you can see where you would want, why they are leaning in on OFDMA as a mandatory feature and leaving out MU-MIMO probably as an option. Uplink MU-MIMO is probably even more sort of on the back burner, because first iteration would probably focus on getting the DL MU-MIMO out in a sort of nice stable manner. There is always questions which people ask, that now you do OFDMA and scheduled access, will CSMA be active? So how would one explain that? That unlike cellular, Wi-Fi still has a distributed access as its core. The only thing that we are doing is that we are trying to make it a little bit more efficient. So even when an access point throws a resource at somebody through a trigger frame, it still can indicate to the users that do carrier sensing and then use the channel, because access point is not privy to what happens around the clients, and so it's better for the clients to check and then transmit. Of course, there are always exceptions where, for example, if you are just scheduling for ACS, you might not want to ask them to do carrier sense, because anyway ACS were not doing any carrier sensing, so you might do that. So that option is also there. Okay. So quick answer is CSMA still is at the core. The only thing is it's a modified CSMA where we are doing a very short time sensing whenever we are scheduling. Okay. But remember that this rides on the fact that before the trigger, the AP did do back off, sensing plus back off, probably even did an RTS CTS to block the nav, and then asked you to check just for safety to not disturb others. Another question which comes about is, now that we have all this scheduling mechanism, how does the AP know what is in the uplink stations sort of buffer, or what they have to transmit? So they have a buffer status report piggyback mechanism where you can, while you are sending data or with null frames, you can attach what's in your buffer, and that can go down to a lot of fine granular level at the QoS access category level, and you can the access point can then use this information and then send the schedules accordingly. Okay. So there are multiple mechanisms. There is a hand raising mechanism. So if I want to ask here, how many of you have questions, instead of sending the mic to everybody, then 20 of you raise your hands. Now I just focus on 20 of you and then give you an opportunity. So that kind of mechanism is also built in, a hand raising followed by tell me how much you have. Okay. And those are all being done very efficiently. The hand raising is done in parallel through some physical layer header mechanisms, and then we have buffer status report. So going through all that, if you look at what 11AX has done, of course, is because of the shorter subcarrier spacing, 1024 QAM, etc. Of course, no change in the streams. We have improved from close to 7 gigabit per second to about 9.6 gigabit per second. Okay, not a big improvement in peak rate. So selling it to clients, I think, will take some work for why they should invest in 11AX. Okay, so we'll see the marketing departments how they come up with that. Interesting other trends are for especially from the sensor side, IEEE is coming up with a wake-up radio as well. So dot 11 radio listening can be quite power consuming. So they are now attaching a possibility of a wake-up radio which can just stay alive, consume minimum power on the sensor side. Whenever it's needed, the access point will just send a wake-up radio command to the sensor, and then the sensor wakes up on that radio and listens to the actual transaction which needs to be communicated. Okay. So that the reason I put that is there is a light chance that somewhere in the 11AX waves of certification this might be mandatory or might be piggybacked along with that. Another thing which is very likely to be piggybacked along with 11AX certification is WPA3, because that's security related, and so you expect a lot of people to jump onto that. So the most prominent one is the simultaneous authentication of equals, or what we call SAE, primarily to protect us from dictionary attacks. But then there are a few other things as well where enterprise gets an upgrade. There are open networks which are getting encrypted, IoT devices getting an improvement from WPS based security. So these are also happening as a part of this family, I would say. But if you look at WPA3 at its core, it's SAE. Okay. What does SAE do? SAE basically solves a problem from WPA2 where in WPA2 an attacker can sniff this four-way handshake, guess passwords and compare it with the MIC values, and if they hit the right MIC, they know that they have cracked the password. Okay. And that's because from the passphrase to the secret that we have, there is a direct path. Okay. You can basically guess a password and then come to the keys. So to avoid this, what we do is now introduce a mechanism by which the passphrase does not play a role in the key generation. Okay. It just more acts like a small gatekeeper which just opens the gate during the initial phases, and so that's why the authentication messages now have a 4-stage process. This was mostly a dummy authentication in previous gens. Now it becomes something like first a gatekeeper and then showing a way for confirming that both of us have a secret key. And so basically this new key that we derive cannot be just directly mapped from the passphrase. And if you want to guess the PMK, good luck, because there are 2 power 128 combinations that you can search. Not as simple as just a welcome 1, 2, 3 dictionary attack and then finding the MIC and seeing that, okay, you have cracked that particular password. There are open wireless networks which are also getting encrypted, and that happens primarily again using a Diffie-Hellman procedure where we share public keys using some standardized group agreement process, and once the public keys are shared, we derive some secrets, common secrets using the public key and the private keys resident inside, and then that becomes the sort of shared secret for us to complete our 4-way handshakes. Okay. And Easy Connect basically also upgrades our WPS by basically having a configurator just reading a QR code from the IoT box and then just being able to share the configuration details with that so that it can then connect to the access point. Okay. So that is a more elaborate protocol based on DPP, and that has a lot of nuances. So it probably takes some more time before we see that in the market, but that's the replacement for WPS that's coming up. So let's look at a few spectrum things. So what's coming up in spectrum is that we have up to about a gigahertz of new spectrum possibility in the US, maybe about 500 megahertz in Europe. So that excites people, and the motivation for that is we have not used the wideband channels because we are already tight in 5 gigahertz, and that means that we are not really doing the peak rates that has been mentioned in the standard. Okay. Big growth in Wi-Fi market, no more space in 5 gigahertz in the sense that people were thinking that we can get the gaps in 5 gigahertz also to Wi-Fi that could not be achieved. Okay. And they tried other spectrum, but they all have hurdles of defense folks there sitting there as well. Okay. So right now there is progress. FCC is very enthusiastic about getting Wi-Fi new spectrum, but there are people who are already parked on the spectrum. So they are asking Wi-Fi to do certain things like say, hey, operate maximum this power, do frequency coordination, client devices cap the power. So this is a FCC recommendation for which the Wi-Fi industry has gone back with a proposal saying, hey, let's do something better than that, let's get some more spectrum in some cases, don't ask us to do this automated frequency coordination for everything, okay. So this is a juggle game because there are people who are incumbents there who are fighting hard against Wi-Fi trying to get this spectrum. And so if this comes and with frequency coordination, especially for outdoor operations, etc., you will find that APs will be contacting somebody with database knowledge in that particular location saying who is operating there, whether you can do this, etc. Okay. At home, of course, we have multiple APs as a big trend, app on the phone, trying to kind of manage this situation, huge market, Eero, Orbi, Google Home, everything, all these things are now the hot things in an app which helps us to onboard devices, etc. Since Wi-Fi wanted this to be interoperable, instead of the problems where we are stuck with one vendor in case we want to extend our network. So they've come up with this easy mesh where basically you now have a controller and an agent role defined by Wi-Fi Alliance, where the controller can now control or rather configure and manage these agents to kind of operate on certain channels, admit certain clients. So all the band steering, onboarding, all those steps are now managed by the controller. Okay. And so there are roles of the controller and agents which are defined by the Wi-Fi Alliance, and we use what is called as WDS frames on the backhaul. So Easy Mesh really does not have a mesh. It actually uses what we call as wireless distribution system. Okay. And that's what I mentioned. In the interest of time, I'll just go there. So my last pitch is what is coming after 11AX. It's extreme high throughput. So we have gone back to the HT, VHT, EHT. We just took a break and went to Hue. So EHT is there because 5G is breathing down Wi-Fi's neck, right? And 11AX did not do a 10x improvement over 11AC, right? And new bands possibly offer some interesting stuff. New technologies coming up to incorporate and get us more spectrum. So what are some of the new things? So if you thought 160 was not getting used, 320 megahertz channels are coming. But 320 megahertz channels with a slight flexibility that we'll be able to bond across bands. So it's something like a interband carrier aggregation that we use in cellular these days very successfully. Wi-Fi has been always TDD and either TX or RX. Now we will see simultaneous TX or RX in an FDD kind of context. Okay, these are proposals, very early stage right now, so nothing confirmed. We also have a lot of fancy techniques similar to cellular multiple antenna systems where we are able to pull multiple access points to send data to a user, coordinated beam forming, all those fancy things which are already in many of the cellular systems. Okay, and HARC could also come to cellular primarily to alleviate some of the errors, with some debates going on about how effective it will be in a collision based system. So just ending this presentation, Nadeem said why don't you share the latest IEEE timeline. So we have this as the current standard. What are the interesting things? AH is dead, AI FastLink is life in what we call optimized connectivity experience. I really don't know what is happening to this except that it's published. 11AX is hot, as we know. 11AY is the upgrade to 11AD. So if you thought 11AD did not have a life, but 11AY is proposed primarily because a lot of outdoor action is happening with Facebook's Terragraph. So 11AY is supporting that. 11BA is the wake up radio, a lot of interest. 11AZ is the positioning, we've been trying to get that. For people interested, always I have questions, what's happening to Li-Fi? Li-Fi is now also coming in as a potential standard. 11BB, vehicle stuff, fighting with cellular for the 5 gigahertz spectrum. This is the one which will be after 11AX. Okay, this might probably get some merger or something happening here. And I think that's all what I have here. So don't worry, 5G is not going to kill Wi-Fi, because we have far too many devices supporting Wi-Fi compared to the cellular, which still does not have many devices on its radar, so it will take a lot of time before we get there. 5G also has an unlicensed offering which is coming to the market standalone, so that might be competition to Wi-Fi in certain segments, not in the home possibly. And to end with the final picture where we see this whole gamut, I'll let you digest that, and I think we'll open up the questions because I'm just out of time. So I'll get Vinod to be mic'd up, please. Vinod, if you can just come here. Yeah, questions, so you can please raise your hands.
Thank you, Srikanth, for the nice overview. These classic questions, issues that we usually face in the new standard. Similar to the 5G, when we are going from the millimeter case, the beacon transmission is a problem even in this case. So how do you are doing beamforming for the beacons?
11AX, see the way Wi-Fi has handled beacons has been quite smooth. As we have upgraded, the beacon rates, if you want to be audible to the previous generation, your phi rates are going to be compatible with the legacy one, and then you beacons have these new information elements that they add. For example, if you typically see a beacon of today in 5 gigahertz, it will have the legacy beacon information, then it will add the HTIEs, and then it will have VHTIEs. So HT stations do not understand that, they will ignore that, and now we will have HE related IEs. So really no difference in the philosophy of how we are going to handle beacons and similar entities like that. We will just add new IEs for the new gen standard, keep the phi rates kind of compatible with the legacy.
That means the range of the legacy devices will remain the same, the lower, and the new generations will have a higher range. Is that
so all the features of 11AX will only be applicable only to the 11AX capable stations. The older generation stations cannot benefit from any of the 11AX related features like the range improvement possibilities.
And how they maintain the backward compatibility with the legacy devices? Like
so the backward compatibility is maintained as usual in Wi-Fi by what we do is in the preamble, we still keep the legacy preamble as the cornerstone of coexistence. Okay. So what we do is still start with the legacy preamble, and that will kind of silence them for the duration of this transmission.
Just block the nav and then just...
It's not even the nav. Nav is a costly mechanism because you have to go to the MAC. So phi header itself will have a LSIG duration which will block that. Yeah. I think, can we get one more question?
So what would be the prices like with all these new technologies coming up?
I'm not the right person to comment on price. I can connect you with somebody who's selling access point. Yeah, Mani maybe can tell the price. Yeah, no. He's from Qualcomm, right?
Yeah.
Yeah.
No, Srikanth, my question was like giving a picture on OFDMA, giving a better range, right? Like we said, like station can transmit at a higher power with just 2 megahertz. But when it is doing a multi-user, how is that handled? Because you cannot always put out that higher power and get the rate, right?
So, and in fact, I think I will leave it to Vinod because he has some information on that. So maybe I'll just skip that so that because he has focused and I've tried to kind of be orthogonal to his presentation as much. So I'll just skip that question because he has some comments on that. Okay. One last question we can take if anybody has. Yeah, can we get a mic to him, please? Vinod, you are ready?
Can you throw some limelight on these Wi-Fi calling features, how it help in AX? Wi-Fi calling?
Wi-Fi calling has nothing specific to do with 11AX. Wi-Fi calling is working today. Wi-Fi calling is just a way by which we are able to use the Wi-Fi air interface and smoothly get on to the cellular core network. And so in fact there is no standard as such for Wi-Fi calling that I am aware of. Please correct any of you if you are working. None of that I am aware of. We just use the existing whatever 11. So today we are using 11AC frames in 5 gigahertz, let's say. Tomorrow we might use 11AX frames for carrying your voice frames. The nice thing is that now you can have multiple voice frames being carried from different users in the same PPDU possibly. So that could be one benefit that you could see out of 11AX. Okay. Otherwise there is nothing special for Wi-Fi calling. Okay.
Okay.
Thank you. I think I'll hand over to Vinod. Yeah, you can come in.